All right, so yesterday we did problems about coins, okay? And we saw that the two main equations you had to set up, one equation was for how many coins you have, one equation was for what are the coins worth. Okay, we're going to see the same kind of thing. We'll set up an equation for how much of something we have, okay? And we'll also set up an equation that has money in it usually. And we're just going to explain those two sentences very generally.
Yeah.
Okay, as I said, we're not going to give a lot of steps. Mr. Roy, do they have a spot to write this down?
They can write it. I mean, if you guys want to write it on the top of that worksheet as notes, you can.
Yeah, put it on the top of that worksheet.
You can even just put row 1 and put an arrow and just put amount.
Yeah, so row 1 will be an amount of something. Okay. In the case of mixing two liquids together, it would be usually measured in gallons of water or liters of water, something like that. Okay. An amount could also be how many tickets did we sell. Okay, we're going to do a problem where somebody's selling student tickets and adult tickets. Okay. And we're going to find a total amount of tickets. The last problem we're going to do is going to be about, I think it's about weight. Okay. We have two different objects, okay? And they're going to weigh different amounts, and we're going to find a total amount of weight.
Yeah, so Mr. Hager's saying row 1 is going to be whatever the amount they're talking about. And just like we did with the earlier equations, the earlier stuff, it's just it's two single letters. It's, A plus B equals 15. C plus B equals 25. This is the amount that you get. Those variables, right, they're always going to be by themselves. There'll be nothing attached. All right, just like we did done earlier.
Okay, and guys, Mr. Wright just repeated what I wrote in parentheses.
Yeah.
Okay, it's the same thing. Okay, so one equation is for how much of the stuff do you have. Okay. And the other equation is going to be written in this form. Okay. So this I would copy down because it's going to help you get the second equation. It's going to be how much something costs or a concentration. When you do a problem, you'll see it's one or the other. So it's a cost or a concentration times an amount, plus another cost or concentration times another amount, equals a final cost or a final concentration times a final amount. So it's really like a concentration times amount plus concentration times amount equals concentration times amount.
Just like you guys did last night, right? For the coins. You had like a nickel and a dime, right? N and D was your first row. And then in the next row, does anybody remember what they did? In row 1, you had the letters, right? You had N and D. Then in row 2, what'd you do? You put the money with it, guys, right? You had like 0.10 N, 0.25, Q. So that's all you're doing here. You're just putting the amount, you're putting the cost of it with that variable. That's all you're doing. It's similar to what we did yesterday. All right, similar to what we did yesterday.
And the main idea, you got to remember too, everything is in a decimal. So if you see a percent, like 25%, you got to write 0.25.
That's what we did yesterday, guys, in the warm-up. That's what we had you take percents and make them decimals, because we knew that we didn't get to the mixture problems, but we knew you were going to need them. So especially, like Mr. Hager said, especially if you get percent, make it a decimal. And when you get percent in those problems, make it a decimal.
That's it for your 2 steps.
That's it.
Okay. So we're just going to try to go through as many examples as we can try to prepare you for before the test. But you need to know both of these steps.
Yeah. The bottom one is more. The bottom one, like Mr. Hager said, is more important, right? Row 2, arrow, and then all that stuff that's in parentheses, right? Cost or concentration times amount plus cost or concentration times amount. Took it up. All right. So the first one we're going to look at. Okay, it's on your homework from last night. Okay, so you don't need to copy anything down on the right-hand side. You already have it. Okay? Just to make sure, is that the first one on your homework at the top of that page?
Yeah, I just gave my kids.
Yeah.
I gave mine. Yeah.
Okay. So first one says how many liters of a 20% acid solution must be mixed with a 60% acid solution? So we're basically taking two liquids, we're going to mix them together. And when we mix them together, this is what I want to end up with. I want to end up with 40 liters of stuff, okay? But I also want it to be a 35% solution. Okay? So we're not going to necessarily mix equal amounts of each liquid. Okay? We might mix more of one than the other. Okay? But I want to get a total of 40 liters, and I want it to be a 35% solution. All right, so step one, we're going to identify the two things in this problem. Sometimes they're people, they're not people in this problem. What are the two things in this problem? Think about what you're mixing. Dominic, you think you know it? Okay, yeah, one of them.
I'm wrong.
It's an acid. What's the strength of it? There's two acids we're mixing together. One of them's a 20%. So that's your first subject. So it's a 20% acid solution. And what's the other one?
So when you're mixing it with.
60%. Okay.
Guys, like we said, give it a chance.
Yeah, we haven't even started yet.
We haven't even done anything yet.
So we've just identified the two things that we're going to mix. Okay? And our goal when we're done is to know how much of each one are you mixing together to get 40 liters at a 35% strength. Okay, 35%.
It's a little confusing because there's a lot of percentages, all right? But look for the two that you're mixing together, right? You have the 20% acid solution must be mixed with a 60%. The two things you're mixing together are your two subjects, okay?
Now, we don't know how much of each one we're going to mix. So how can I represent something I don't know?
X and Y.
Sure, you could pick X and Y. So when we're done, we're going to find out what X and Y are. Okay, now our first equation. Okay, I said it's going to be for the total amount. How much of the stuff do we have?
So guys, in this problem, right, what are we using what's the unit of measure, like inches?
Liters.
Liters, right? How many liters, KJ?
40.
40 liters. Look for those key words, like Mr. Hager said earlier. Tickets, gallons, whatever numbers attached to that is your overall amount, okay?
So it'd be X plus Y equals 40.
Right. We don't know how much of the first one we're going to mix. And we don't know how much of the second one we're going to mix. But I know when I mix them together, I know the total. So when I add them up, I'm going to have a total of 40 liters of stuff. Any questions on that equation?
No.
Now, what do I have to do when Mr. Rice says line up?
Subtract Y.
Subtract Y, and what's that going to do? It's going to get what letter by itself?
X.
Good. Okay. So who can tell me what X will equal when you move the Y to the other side? You're going to subtract Y, subtract Y. So what's X equal to?
40 minus 12.
Right. Okay. Now, KJ decided to solve for X. You could have solved for Y. It doesn't matter. Okay. Could have solved for either one, as long as you get a variable by itself. Okay. Any questions on this part? Okay. Now we got to do the second equation. Okay. The second equation has to do with the percents. We need a concentration times how much of it we have. Let's look at the 20% solution. How would you write 20% as a decimal?
1
Brian? 0.20. And how much of that 20% solution do we have right now? We have x. Let's look at the next one. We have a 60% solution. Okay. Joe, how would you write 60% as a decimal? 0.60. And how much of that 60% solution do we have? Y. All right. So notice what we just did. We have a concentration times an amount. We have another concentration, 60%, times an amount. Now let's fill in to this formula. Concentration times amount plus concentration times amount. So just remember that it's a plus. So we've got 0.20x. What comes after that? That's concentration times amount. What comes after it?
6 plus
Plus
60 less.
another concentration times another amount. Equals. Let's go back and see what it says. Final concentration times final amount. Once I mix all this together, what percent do they want the solution to be?
35.
They want a 35%, which is what as a decimal?
0.35.
0.35. Okay, that's my final concentration I want to get times my final amount. What's the final amount? How much am I going to have when I'm done? 40.
You guys, you can just leave it at 40 because it wasn't a percent to begin with, so you can just leave it as 40. It's okay.
Okay. Any question on that step? So concentration times amount plus concentration times amount equals final concentration times final amount.
Anybody, now guys, when we get to this point, it's the same as we did yesterday, the same as we did on Monday. Anybody want to take a guess on what we need to do?
Look back at that equation 1. What can you do with that?
Oh,
Yeah?
you have to write 20 or 0.20 and then you have to plug that into the next step.
Yeah.
Just like we did with the coin problems yesterday, just like we did with the age problems on Monday.
Okay, so we have x by itself. Everywhere you see an x in that second equation, you're going to change it to 40 minus y. Does anything else change after that?
No.
No. We'll talk about that last part in a second. Now this last part is 0.35 times 40. Okay? This is a calculation. Why don't we do it out? Okay? We're going to have to do it out eventually. 0.35 times 40. 0.35. It's 14. Any question on how I just got 14? Just multiplied 0.35 times 40. Okay, who can tell me what I do next? Okay, someone said, Kayla said distribute. Sam, what am I going to distribute? 0.20 to the 40? Where else? To the y. Okay, even if you think you know this, just use your calculator to double check it. Do 0.20 times 40. 8. Minus? Now, Ben, how would I write 0.20 times y?
Negative 1. Negative minus, I'm sorry.
Yeah, just have to write down 0.20 and y. And it's subtraction because there was subtraction up above. Just copy that down. Rest of it stays exactly the same. Okay. Now look at that carefully. We've talked about this. We've used a 3-letter abbreviation a lot for it. What do I do next?
Combine like terms.
Combine like terms. Very good. What are my like terms, Savon? Savon, what are my like terms? Savon?
20y, negative 21, negative 20y, and 6.6.
Yeah, we're going to combine those y's. Okay. Negative 0.20 plus 0.60. Okay, if you type that in on your calculator, anybody think you know what you're going to get? 0.40. Okay, good. Two steps left. All right, go ahead, Kayla, you can tell me.
Subtract the 8 from each side.
Subtract 8. And how about Eli? When I do 14 minus 8, what does that give me?
14 minus 8, Eli.
I know.
You know 14 minus 8. Use your fingers if you got it. 6. Okay. And Isaiah, what's my last step?
Oh. Divide.
Good.
Don't ask me what the answer is.
No, we're going to use a calculator. But what do you? Just tell me what to do.
You divide by.
0.40.
Thank you.
Okay.
Guys, you don't have to put the 0 in front of it if you don't want to. 0.40 is the same as 0.4. It means the same thing.
And now just use your calculator. Divide it. See what you get. Okay, we get a nice answer. 15.
How the hell do you get 15?
Please watch your language, Isaiah. What's your question?
How do you get 15 by dividing? It's confusing.
It's a decimal, dude.
When you divide a number by something less than 1, it gets bigger. It's just the way it works.
Oh my god.
So take 6, divide by 0.4, we get 15 liters. Okay? So now we know how much of which solution was y? The which one? Y is which one? Y is 60%. Okay? So now we know we need 15 liters of the 60%. Does everybody have the work up to the 15?
Yeah.
Take a second or so, write it down. And guys, that's why it's important tomorrow. I mean, Mr. Hager has some calculators, I have some calculators, but if you have one, bring it tomorrow. Right? If you have a calculator, try to bring it tomorrow.
Yeah, L just stands for liters. 15 liters. Okay. So as Victoria just said, now we know how much of the 60% we need. It's 15 liters. Okay. Now I got to figure out how much of the other one I need. How do I get X? Plug in Y. What's Y? Okay. So what would be my equation for X? X equals what? 40 minus 15. So how many liters of the 20% do I need? 25. Okay, so if I have 25 liters of the 20%, and I mix that with 15 liters of the 60%, I'll get exactly what they want. A total of 40 liters, and the strength of it will be 35%. Okay. Any question on that mixture problem?
You guys, those are a little confusing because you have the 3%, right? You have that one step at the end where you have to take how much of the solution you have, and then multiply it by the amount. It's a little bit different than what we've done so far.
Anybody have any other questions or need to see any part of that
Does
again?
anybody else need to see any more of this? Any part? Okay.
Everyone's okay? Okay. So Mr. Roy is going to go through the next one. You do need to write this one down.
Yeah, guys, you know what? If you don't want, it's kind of hard on there to find the space to do it. So let's just follow along, okay? We're not. I just put in big bold up here, right? We're not the number 2 on that front side of that homework. We're not going to use that. So I want everybody right now, so you don't get confused, to cross it out. You don't need number 2. We're not doing that one. Yeah, number 2 that starts with, it says a scientist. This is the same problem right here. Cross it out. We're not using it.
Keep the table though, yeah.
Yeah, we need the box, so we will need the box. We're still gonna need the box. All right.
You guys are gonna fill in the box.
Fill in the box the best you can. We're still doing the problems. Anybody need a new copy?
Yes.
So guys, while I'm giving these to you, at some point I would suggest maybe transferring number 1 on here. Who else? Anyone else need a new one? Travis, you need one too, but I saw you brought it on. Let's try it. Anybody else? Going once, going twice? Okay.
I agree with Tyler.
Hey, I'm this close. All right, so this is the problem we're using. Guys, if you don't want to write it on your sheet, you don't have to. All right? Right, Lauren? Okay. So, a family bought 8 movie tickets. The tickets cost $12 for adults, $6 for children. The family spent $66. How many adults and children went to the movie? Anybody know, down from my area, anybody know Mr. Bergeron?
Yeah.
Mr. Bergeron came up with this question. Just so you know. I'll tell you that. So, 2 subjects, right? 2 things that we need to find. Tyler, what do you think one of those things are? Obviously, we're trying to find the price of what? Tickets, right? We're trying to find the price of tickets. But there's, just like in the last one, it was acid solution, right? There was particular kinds. Just like with the tickets, we have particular kinds.
Just be careful, are we finding the price of tickets or how many? How many,
right?
Like how many?
But there's particular kinds, right? So one kind is what, Tyler? What's one kind of ticket that can be sold? Children ticket. And what's another one that can be sold? Adult ticket. So, Tyler, what are our 2 subjects going to be?
We'll call it A.
All right, we're going to call it A and what?
Adult and children.
Adult what?
Children. I don't know.
What are we trying to find? Tickets, right? Easy back there, you sicko. Right, we got adult tickets. What's the other one, Tyler? Children tickets. Children ticks. And Tyler, how did you want to represent those? Turn around, please.
A and C.
A and what?
C.
A and C, okay. A and C. Excellent. So a family bought 8 movie tickets. We need this information. We need that information for row 1 to set up our equation. We need this information here, all right, for row 1. Victoria, just like we did with the last one, right? I forget, we added the 2 solutions together, right? Did we not? We did, right? What do you think we're going to do with these 2 types of tickets? Add them together. How would I represent that? How would I show that? So what am I doing? A. What am I doing with these 2 things? So I put A, then what? Yep. Equals how many? How many tickets overall? That's 66. That's money. How many tickets overall? How many did they buy? 8. Right? They bought.
Equation for the
8.
amount.
All right.
Okay, that's your equation for the amount.
That's our equation. This is going to be our equation for amount. Not money. This row has nothing to do with money or percent or anything like that. This is like we've done all this week. It's just going to be a single. It's going to be a single letter, a single variable. All right. So A plus C equals 8. Now, Shazi, what's wrong with that? What do I need to do? Like we've done all this week. What do I want to happen? just like we did with the last one. Shazzy, can I ask Savon? Savon. All right, what do you got, buddy?
You want to get one variable by itself.
So what would you do, Savon?
Subtract.
Subtract what? Subtract C, right? Minus C, minus C. That gives me what up here, Savon?
A equals 8 minus
8 minus C. Good. Sounds good to me, right? So row 1 right now is good. Row 2 is all set. Can you please put your eyes up here? You understand me? Now I'm starting to get upset. So we get 8 minus C like Savon just said. So we handled all this. I'm not worried about that anymore. We did it. Now we're getting into like the amount or the cost. So in this case, are we dealing with like an amount or a cost? Cost, right? So at the top of my row 2, I'm just going to put a little money symbol. So we're dealing with cost. This box right here, the adult tickets. What's going to go there, Ben?
Adult ticket.
How much is an adult ticket? How much is an adult ticket? 12, right? And just like I did with the money yesterday, what do I have to attach to that? With the coin problems? What's the variable for adult tickets? Hey, nice, good.
That's your cost times an amount.
Matt, what's going to go in the children's ticket thing?
Six.
All right, 6, and then what's the?
C.
C, good.
That's your other cost times an amount.
Now, to do this equation for row 2, everything's based on, for the majority of it, everything's based on row 2. So KJ, what's that going to look like?
12A plus 6C.
12A plus 6C equals what?
66.
$66. Mr. Hager, are we missing anything?
Yeah.
We're good, right? Because we're not trying to get like there's no like, it's already telling us overall how much the tickets cost. It's $66. The last one, we had to like multiply 2 things. We don't have to do that for this ticket problem. We don't need to do it. All right? Tyler?
I was going to say I'd do the next part.
Oh, you want to do the next part?
Sure.
Good, right? I know it works out. All right, so Tyler wants to try the second part. All right? So, Tyler, hold on a second, Mike. All right. So what do you think, Tyler? Tell me.
12, and then parentheses, 8 minus C.
Yeah.
And then close parentheses, plus 6C equals 66.
How'd you get that?
Just my brain cells.
All right, but how'd you know to put this 8C?
I use my brain cells.
A equals.
Yeah, A equals, right? All Tyler did was took this, plugged it in for this. That's all he did. All right? Now, we talked about this in the last one. We got to do that now. We're going to do the same thing we did in the last one. Tyler wants to try again.
Multiply.
All right. Do you know
The 12 times 8.
which is?
90, 94,
Close.
96.
96. All right, keep going.
That comes from your brain cells too fast.
Yeah. Minus C. Plus 6C equals 66. And then you add the 2 C's. Watch them tomorrow.
Come by like terms, right? What do I get? Negative 12 and a positive 6?
Negative 6C.
96 minus 6C equals 66.
Yellow social.
And then subtract the 96 from the other side of the equal sign. And then you get negative 30. And you divide the negative 6C by negative 30.
What am I dividing by?
6, negative 6.
Good.
And
Good. C equals 5. Nice job, Tyler. All right, Tyler went through. He did distributive. Then he knew he had he had the two C's on the same side of the equal sign, so he combined like terms. Then he said, okay, I want to get that negative 6C by itself, because there's nothing else like it. There's just numbers. He did that. He subtracted 96. Then he did the last thing was this division. That's just solving an equation, like we've done this year. Now, Travis, to go back and to get how many adult tickets we need. What do we do? Hey, nice job, right? Go back to this. A equals 8 minus C. A equals 8, and like Travis just said, C is 5. A equals 3. And like Mr. Hager did in the last one, we go back up. They bought 8 tickets. We go back down. We had 5 children, 3 adults, which gives us the total of 8. That's what it is. You all set, Austin? I don't know if we should send it down to Cosmo and get her hair. What do you think? All right, so good. All right, that one wasn't that was a little bit. That was a tiny bit different.
That was easier.
Because we didn't have to multiply something here. It already gave us the amount it already gave us the total amount of money, or the total amount of the whatever. It already gave us that. The last one we had to multiply. This one we didn't. Okay.
Did everyone see how that was still kind of a mixture problem, though? It's a mixture of adult tickets and student tickets. Okay, so it's still a mixture problem. Okay, last one we're going to try to do. This is on your worksheet. Okay, and we're going to be mixing 2 things again. Okay, it says an assortment.
Guys, this one got screwed up in your worksheet. For whatever reason, it got numbered as 6. It should have been number 3. We're doing the last one on the front side.
It says an assortment of nuts costs $36 for the entire box, and the total box weighs 5 kilograms. The box is going to consist of 2 kinds of nuts. There's going to be pecans in it. Pecans sell for $7.50 a kilogram, and almonds. Okay, the almonds sell for $6 a kilogram. Okay. Basically, I want to know how many kilograms of pecans are in the box, how many kilograms of almonds are in the box. And we can figure that out because we know 2 things. We know how much the box weighs once we mix everything together. We also know how much the box costs when we sell it. Okay? If we didn't have one of those things, we couldn't do it. Okay? So what are my 2 subjects? Think of the 2 things we're mixing. Yep.
Pecans and almonds.
Pecans and almonds. Okay, what's a good letter to represent pecans?
P.
P. If you pick a letter that begins with the first letter of that word, it makes it simple. Almonds?
A.
A. All right. So our first equation we're going to write, this is for the amount. Remember, the amount is not the cost. It's how much of it do you have. How much does it weigh? How many gallons? How many tickets? Okay, it's a how many thing. Okay? How much do we have when we mix the 2 kinds of nuts together? We have a total of 5 kilograms. Now, the 5 kilograms is made up of what kinds of nuts?
Almonds and pecans.
Okay, pecans and almonds.
B plus A.
P plus A, good.
Guys, most times in these mixture problems, or in the ticket problems, you're just taking the 2 variables you put in the first row, adding them together, and equaling whatever the amount is. Whatever the gallons is, the liters, the amount of tickets, whatever. That's all you're doing. So most of the time when you're doing these kind of problems, you're going to have to line up. You're going to have to move something around. Okay?
Okay, and there's not that many options for what you're going to get for answers here. Okay? P and A have to be positive, and they have to add up to 5. Okay? Now we got to get either P or A by itself. You can tell me how to do that. Savon?
Subtract P, because I like having A on the left side.
I'm going to have A on the left side. So what is A equal to?
A equals 5 minus P.
5 minus P.
I don't want A on the side.
Okay. Our row 1 equation is done.
Mr. Hager, Dominic just asked, is it okay if we have P equals 5 minus A? That's fine too.
Yep.
Either one works.
Either way would work fine.
Yep.
All right. Next thing we need to find. We haven't used how much each one costs per pound. All right? So that's the next part. How much do pecans cost per pound? $7.50. And how many pounds or how many kilograms do we have right now? P. Right? How much do almonds cost? How much do almonds cost? Yep, $6. Okay, if you want to write it as, where'd you get the 6 from? Oh, there's just no dollar sign. $6 per kilogram.
Am I allowed to call?
How many kilograms of almonds do we have?
A.
A. Okay. So in this row 2, it's always a value, usually in money, times an amount. A value, okay, usually in money, times an amount. Okay. Now, what's the total cost when we mix all these nuts together? How much is this box going to cost?
$36.
Okay. Well, that's given. Cost $36. Now, remember what the formula said. Go back. It's a cost times an amount plus a cost times an amount. Okay, so let's fill that in. Okay. In row 2, here's my first cost, $7.50 times an amount. So write that down. Plus, what's going to come after that? Yeah? What's going to come after the 750p? 6a. Okay. This is our second equation. Okay. What do we do from here? What have we done every time? You're going to plug in what? What's a equal to? 5 minus p. Where are you going to plug that in? For a. Just like that. Is anything else going to change? Nope. Everything else stays the same. So you get 750p. Okay, Eli, what's a again? 5 minus p equals 36. Austin, what property do I have to do with the 6? And? What property is that? Distributive. Distributive. 750p. Ben, 6 times 5? 30. Minus 6 times p? 6p. Okay, once you do that, you should always have some like terms to combine. Usually whatever the letter is, you should see it twice at this step. Okay, Sam, what are my like terms?
7.50p and 6p.
Yeah, 750p and negative 6p. Okay, so Isaiah, what am I doing right now?
You're multiplying 7 point. No, you're adding them together.
We're subtracting, taking 750p minus 6p. Okay, so combine your like terms. Yep, still got the plus 30. Equals 36. Oh, no negative, sorry. So $1.50 P plus 30 equals 36.
Subtract the 30 aside.
Okay, I want to make sure everybody understands that. Tyler just said subtract 30. Does everybody see why you're subtracting 30?
Yeah.
Okay. Tyler, what's 36 minus 30? 6? Okay, Tyler, you doing good? I'm sure you got this, but somebody else. What's my last step? Say it. Divide by what? 1.50p. Which is 1.50. And p is 4. Okay. What is that for?
P.
Well, what about the pecans? It was a weight.
4 kilograms.
4 kilograms. Okay, so now we know we have 4 kilograms of pecans. Okay, what's the last thing I need to find? A, which is how many kilograms of, what's A stand for? Almonds. Okay. What's my formula to find how many almonds I have? Justin? It says almonds equals what?
5.
5
Minus P.
minus P. What was P? P was 4. So Justin, what's my formula to find how many almonds I have? 5 minus 4. Okay, guys. Guys, stay with us. Okay, so we get 1 what? 1 kilogram. Okay, so if you're going to mix 1 kilogram of almonds with 4 kilograms of pecans at this price, your box is going to cost you $36, and it's going to weigh 5 kilograms. Okay? Any questions on that problem? Does everyone see how that's a mixture problem? You're mixing 2 things together? Okay? So all these problems are about mixtures. All right, so the homework tonight will be a study guide, okay, for sections 12.7 and 12.8, and you can use that study guide on the test tomorrow.